This week we started with chapter 3, right? So right now we are working on chapter 3, systems of linear equations and inequalities. And on Tuesday we saw how to solve a system of linear equations by graphing. When you're graphing a system of linear equations, usually on the system of linear equations we have two equations, two variables each equation, right? Two variables. And when you're graphing, you're going to find two lines, two straight lines that will represent, each one going to represent one equation. We have three situations that we can find when we are graphing. The first situation is when the graphs they cross in one point, and this is when we're going to have one solution for the system of linear equations. The other situation, the second case, is when the graph, the lines, they are parallel. If they are parallel, then they will have no intersection, they will not cross at any point, so they will have no solution. And the third situation, the third case that we have here, is if the lines, they are one on top of the other. They are the same line, on the same place, on the same spot. That means you will have infinitely many solutions, or infinite solutions, and there are some special names. For the second case, when you have no solution, the special name is this. It's going to be inconsistent system. And for the third case, when you have infinitely many solutions, there's a special name. It's going to be a dependent system. Okay? So those are the three cases that we will find when we are solving linear equations, system of linear equations in two variables, and we will find these one of these three situations. How to answer the first case? You're going to answer with the ordered pair, with the coordinates of the intersection. And in this case, in this example here, you're going to answer parenthesis, x equals 0, comma, y equals -2, close parenthesis. This is the answer. How are you going to answer if it's the second case? You're going to answer like this. No solution. This system have no solutions at all. The code or the notation that we're using for the quiz is this, NS. But remember, this is not a math notation. This is just for our quiz. This is just for our quiz. If you need to use math notation, you can use this. This is the symbol for no solution, or even an empty set. That means no solution. How to answer to the third case? In the third case, we're going to have infinitely many solutions, or infinite solutions. And in our quiz, we are using this notation, this code here, IS, infinite solutions. Again, this is not math notation. This is just for our quiz. If you want to answer in a test, like an SATs or something like that, you have to say this. You have infinitely many solutions or infinite solutions. This is a very brief summary what we have seen this week. And yesterday we worked on this. We worked on solving this system of equations. And we have here two equations, equation number 1 and equation number 2. Equation number 1 was in blue and equation number 2 is in red. Okay? So we have these two equations. Remember yesterday we used the slope-intersect form. We changed each equation and made it look like the slope-intersect form, like this: y equals mx plus b, right? That's how we've done. That's how we solved this kind of system, this system of linear equations yesterday. How do we do this? We move, for instance, for equation number 1, we're going to move everything in the left hand side. We're going to move to the right hand side of the equation, move everything, and just keep y. Y, keep on the left hand side. Do the same thing with the equation number 2. Move everything that's on the equation to the right hand side of the equation and keep on the left hand side only y. That's how you do. And at the end, we were able to draw, we were able to represent the lines here on the graph. One line, this here blue, the other one red, and then we realized both lines are parallel lines. They don't touch each other, they don't cross in a point. So this is a typical case where we will have no solution. Okay. Any questions so far? Good morning, Arelis. Good morning. Any questions so far? And this is a review, what we have seen so far, what we have seen about graphing, solving linear equations by graphing. This is how you do by hand, how you calculate, and then you find the slope, you find the y-intercept, and you plot it on the graph by hand. And you can also do, as we are doing in the quiz, using your graphing calculator, using an online tool or your own. If you have a graphing calculator, you can use your own graphing calculator. Today we will work on another kind of problem, and this is a kind of problem that have no solution, right? And remember, this is the kind of system that's inconsistent case, inconsistent system. Now we're going to see a dependent system, a case where we will have infinite solutions, how it works, how it looks like. We don't know it yet. We still have to solve it. Thank you, Veronica. We still have to solve it, but I can tell you this will be a case of infinite solutions. Let's check. And we have equation here, equation number 1. This is equation number 1. The next one we're going to call equation number 2 in red. Equation number 2. And let's solve it by hand. Let's solve by graphing, finding each equation in the slope-intercept form. So change it and make it look like the slope-intercept form with the slope m and the y-intercept b. That's what we're going to do with equation number 1 here, which is x plus 4y equals 8. So move everything to the right hand side of the equation and keep on the left hand side only y. We will keep only y on the left hand side. So let's get rid of this x here, subtracting x on both sides. And then we have 4y equals negative x plus 8. Okay. Now we need to get rid of this 4. We still don't have only y. We want to have only y on the left hand side. So get rid of this 4 by dividing both sides of the equation by 4. And now we will have y equals negative x divided by 4, negative 1 over 4, times what? Times x plus 8 divided by 4, 8 divided by 4, 2, plus 2. This is the equivalent of equation number 1, but now it is in the slope-intercept form. Let's work now on equation number 2. We finished with equation number 1. It is now in slope-intercept form. Now let's check equation number 2. But look at equation number 2. Just equation number 2, we have y equals negative 1 over 4 x plus 2. This is equation number 2. what can you see? If we're thinking about changing anything to make it look like the slope-intercept form, we realize we don't need it. We don't need to change. It is already in the slope-intercept form, right? Y equals -1/4x plus 2. It's already in the slope-intercept form. You don't need to change anything at all. And another thing, compare equation number 1 with equation number 2, and they have the same slope, -1/4. They have the same slope. They have the same y-intercept. That means they are the same. They are equivalent. They are equal, actually. They are equal. And this is what happens when you have a system with infinite solutions. Dependent system. The equation, the first equation, after you change it, after you make it look like the slope-intercept form, and do the same thing with equation number 2, you're going to compare, you're going to have the same thing, you're going to have equal equations. Because equal equations will produce equal lines, the same lines. Let's graph the equations that we found here on this coordinate system, the rectangular coordinate system. Y-intercept. Y-intercept is this one, B. Y-intercept is here, +2. And the slope, -1/4. -1/4 is going to be rise over run. So let's draw here the slope, rise over run. Run is going to be 4. And rise is -1. So it's not rise, it's going down, actually. And this is the next point that you're going to find. Here's the next point. Now draw a straight line between the points. Draw a straight line. And let me try to make a straight line here. Yeah, kind of. Let me try again this. Yeah, kind of. Pretend this is a straight line, okay? The first equation, the equation number 1, if we graph it, is going to be the same line, this line here. Equation number 2, if we graph it, is going to be the same line, because they have the same slope, the same y-intercept. That means the intersection between one equation and the other one, the one line and the other one, is going to be infinite points, infinite, all the whole length of the line. So these have infinite solutions. This is what we mean when we talk about system of linear equations that have one line, the other line that we're going to present is one on top of the other. They will have infinite solutions because the intersection of both lines are going to be the whole thing, the whole line, the whole length of the line, all the points. Infinite solutions. Okay? That's it. That's what I have to show you about graphing and solving linear system of linear equations by graphing. Tell me if you have any questions. I know sometimes I talk too much here. Sometimes I don't stop to check if you have any questions, but forgive me. Let me know right now if you have any questions, if there's anything that's not clear, or if you have any complaints, or anything at all, feedbacks, what I can do better, anything at all. This is the last thing I would like to present about graphing linear equations and graphing systems of linear equations to find the solution. Next week we're gonna check, we're gonna know how to solve system of linear equations using different methods. No more graphing. We will have some review about graphing, but you're gonna find out how to use different methods. But make sure, be aware that every method that you choose the answer needs to be the same. There's not going to be a case that you find different answers. The answer is always going to be the same. I think we are ready to work on the quiz today, okay? If you don't have any questions, let's move to the quiz. And before working on the quiz, as usual, before working the quiz, let's try the bell work. Let's check the bell work. If there are no questions, let's try the bell work. And this is the bell work today. Is 40 miles per hour. 40 miles per hour. They are going towards each other. They're going to meet at some point. Let's say they're going to meet here. The train number 1 is going to travel this distance in 1 hour. Train number 2 is going to travel this distance here in 1 hour. How many miles train number 1 travels in 1 hour at 60 miles per hour? In 1 hour, how many miles will train number 1 travel? At 60 miles per hour, train number 1 will travel 60 miles, right? In 1 hour. How many miles will train number 2 travel in 1 hour at 40 miles per hour? Well, train number 2 is going to travel 40 miles in 1 hour, right? That means they're going to meet at this point. This is where they will meet. They will be at the same place, at the same point. And the distance between the trains that makes them apart, that makes them away 1 hour, is going to be 60 plus 40, 100 miles. 100 miles. So the answer here is 100. 100. This is the right answer. The objective here is not finding the right answer. Don't worry. Thank you all for the participation. And yes, if you choose something, I think Jorge was the closest one with 30, because it's more than 20. But thank you, Dariani. Thank you, Roberto. Thank you, Veronica, Timothy, Jorge, Adriana. Thank you, Angel, Kimani, Jan. Thank you for your participation. That's the objective. That's the purpose. Is to get ready for the quiz. Is to get in the mood. To get in to get the brain active and warm for the quiz. The answer is going to be 60 plus 40, 100. Moving to the quiz, and the quiz today is very straightforward. It's kind of the same thing we worked yesterday. It's slightly different because I give you options here, give you options of graphs. So let me show example letter A, question letter A. How would you work this out? And the question is, solve each system of equations by graphing, match with the right numbered graph. So we have here this system of equation, okay? And you're gonna use, if you want, the graphing calculator. Type each equation into the graphing calculator. So the first line, 4x plus 12y equals 4, and enter. And the second line, y equals 5x plus 11. Oops, 11. Enter. Check if the equations are correct. If you type everything right, then let's check now the results. And this is the results. Oops. Okay. This is the results. The intersection is going to be here on x equals -2 and y equals to 1. I like to use some colors. Let me color this blue, this red, and this is the result. Now we're going to compare. We will compare with the options that we have. Here the options, and we need to find one where the intersection is -2 and 1, right? Let me check again the intersection. X equals -2, y equals 1. And try to find one where the intersection is x equals -2 and y equals 1. And we found one here. Now let's compare. This is -2, y equals 1. Compare with the solution that you found. And it's the same shape, right? The same graph, looks the same, have the same intersection. That means the answer for letter A is going to be 8. This is the answer for letter A. A is going to be 8.